national list is going to work well with the Thai people or not. Okay. Now we can have even the marker or the SNP, but she requests that we are not going to reveal in this meeting. You know why? Because we would like to have this information published first, okay, for Korea, and then you will all know, okay. And also, this is very interesting that this second meeting, we also will talk about the pharmacogenomics application to augment the national list of essential medication. I'm really delighted that now we have the communication with all your people, Food and Drug Administration people. And also the pharmacovigilance meet pharmacogenomics, okay, more and more. Now, pharmacogenomics is like a penetrate into all the existing very important decision maker in Thailand. It may take some time or take for a while to be fully implementation, and we also have our friend from Singapore to join the panel. Okay, we finished with the pharmacogenomics a little bit, and then we will start a little bit on the personalized medicine, but on the medicine rare diseases. That is quite different from the pharmacogenomics. Pharmacogenomics, you're talking about the polymorphism that above maybe 1%. Now we're talking about something less than 1%. The technology, the way we do analyze, totally different. Okay, but it's fun. Okay, somehow we try to look for the mutation. And all that we have is all the instrument. We do some whole genome or exome, and now we're going to send one of our capable person to be with Liken to learn more on this type of technology and how to analyze the data. And we need to do this first, and then we have a question. And once we have a question, we need to find a guru to help us to improve our ability to do that. And in the future, we plan to have what we call clinical genomic unit in Thailand within 1 or 2 years from now. And then for the sequencing part, we do what we call amplicon sequencing. That what we can do the amplification, maybe more than 10,000 PCR primer involved, and then to do the sequencing at the same time. For this, we quite agree with the Dr. Objun. He is the clinical molecular geneticist to create what you call the panel of the inherited diseases, particularly for Thai people. The existing panel is too large and too expensive, and we will try to design for a particular group of disease, and using the next generation sequencer, and the pricing will come down, and all the list of the rare disease has been created. Okay, you can see that for the way that we do is that we need very capable people who can run the next gen. Next gen can hardly be a fully automation right now. A lot of steps have to be involved, and after that you need a bioinformatician. Okay, if you do the genotyping, just genotyping, there's no need for you to need a bioinformatician. But if you do the exome sequencing, you deal with a huge amount of data. You need a smart guy like him, sometime, Dr. Ekawat, to help us to do the data analysis. After that have been analyzed, you need another person, what we call clinical molecular geneticist, to interpret, to make that data become available, then clinical interpretation ready to send to the doctor to be utilized. Okay, so it's not just simply you send the the DNA to the certain lab, and then you get the 3 or 4 pages of the outcome, and you expect it to give, you hand it to the doctor. It's virtually impossible that would work. And again, tomorrow, everything has to be tomorrow because we have 2 days. Okay, conference, no Thursday. And you can see what they are doing from exome and aberrant sequencing as a tool for diagnostic for rare genetic diseases. For the Dr. Jun, he's the MD, and the MD PhD, and the Dr. Ekawan will present you tomorrow. I know that the Dr. Ekawan is preparing a lot of things for you to show you. For the rare disease, right, it's very rare. Last is a very famous family. You call it, her name is the Alexis, okay, Alexis Berry. If you search from Google, you can see her all the way. This is what she happened. She have the mutated gene that can produce a neurotransmitter to type. And what happened to her, a lot of the clinical complication, she can hardly even move her organ at all. And now after doing the sequencing and find the mutation, then just supplement what she needs, she become like this. Okay, so there's no need but she have to suffer about 15 years because of the technology not quite ready yet. But now, why you have to let that child suffer? Okay, and there's no need for you to do the whole genome sequencing because I met this one, the Professor James Lusky, who do the James Wasun genome sequencing. And he now said that you can do exome because all the information is in the area of the gene, not outside. If you do whole genome, it's totally useless now because you cannot interpret any data beyond the scope of gene at all. This is what called genetic and genome-guided personalized medicine of cancer. You have the the young scientist called the Natini Jindawat. She's been there in Britain for quite some time and in US and come back. She is what she calls herself. She's an MD PhD, a clinical molecular cytogeneticist. Okay. And all that she do is she will collaborate with us to come up with the panel aberrant sequencing on particular cancer of interest in Thai population. And tomorrow, actually now she has some data at the same time, similar to another group previously, that she can hardly review some in detail. Just wait for the information published in the literature. And tomorrow will be somatic mutation, profiling of a non-syndromic early onset colorectal cancer using next generation sequencing technology. You can see that this not really happen in our lab, but somewhere else, right? For the, let's say, the melanoma, they can now sequence the cancer genome before treatment and try to find the target, drug target. And after prescribe the drug target, the cancer can shrink. Okay? You can see that before and after treatment, but it's not last long, surprisingly, that after that, there is a lot of chance that they will develop cancer again, and you need to find another drug for him or them. So, finally, we come to the conclusion that this is purpose of the T cell. Number one, to create, develop, improve, and increase efficiency to add value to Thai pharmaceutical and life science product and services, create and expand a collaborative network for development and investment in life science for health, promote and support investment and joint investment in life science in Thailand. That's what our project try to proceed according to the purpose of the T cell. And our project actually emphasize on product and services in pharmacogenomic and genome-guided personalized medicine for life saving and medical expenses to reduction. Ladies and gentlemen, I leave it for you to judge whatever I try to explain it to you, and it would be like what I try to emphasize or not. Thank you.